In this lecture, I will talk you through the theory and principles of collecting optical remote sensing data. So just to reiterate, and this is something we covered in the previous section, passive remote sensing is a form of remote sensing in which Earth or the target on Earth is illuminated by solar radiation, and the radiation or the reflected energy reflected back from Earth is captured by the optical sensor. Multispectral data is another term given to optical data, and this is because the sun and whatever is illuminated around us by sun is present across an electromagnetic spectrum. So when the solar energy is beamed onto the Earth, it comprises of an electromagnetic spectrum comprising of different sections across different wavelengths, and this is what enables us to see the world. So visible light is how we see the world, and that is present across a given wavelength range of the electromagnetic spectrum. And when the optical energy is reflected back, what it comprises of is of multiple spectra which have different wavelength ranges. So what you see over here is the electromagnetic spectrum, and this is what the optical data sensors capture. They capture the reflected wavelength across a number of different wavelength bands or electromagnetic spectrum, and this is where the multispectral bands come about, and all optical data comprise of multispectral bands. And usually the multispectral bands, they comprise of visible light wavelengths, infrared, shortwave infrared, and thermal. We can only see visible light, and rest of the infrared, the electromagnetic components are unseen. Now, different materials on Earth have different properties, and the spectral reflectance properties are therefore different. So water comprises of a different set of materials, forests, they comprise of a different set of materials, soils, they comprise of a different set of materials, and the spectral reflectance properties are therefore different for all of these materials. And essentially this is what the optical sensor will capture, and that is how we distinguish between the different components on Earth. So the vegetation properties, as you can see over here, are very well illuminated in the near infrared, red and green bands. So visible spectrum comprises of RGB, red green bands, followed by near infrared. So the reflectance properties of vegetation, they really peak in near infrared, and essentially this is what we are going to focus on in the rest of the course, because we are going to map different forest types and land use types further on in this course, and we are going to make use of these three vegetation bands of the electromagnetic spectrum to carry out the different mapping activities. There are a number of different multispectral optical data sensors that there are. In this course, we are going to mostly cover Landsat, but before doing so, I'm also going to introduce you to some other sources of multispectral data that there are.